I forgot that the videos here cut out at 15 minutes. I was so close! So close. Okay, so here's the end of this. So we're looking at problem 14. So go ahead and try it on your own. Come back, see what I do. Okay, so hopefully you stop problem 14 right away, because you should recognize that what's the difference between problem 14 and problem 13? Nothing. You even proved this in the lab. Either you did it live and in person or you did it with the simulation. But we know that moving the resistors around in terms of putting them in series in different orders, I'm here using air quotes for the orders, doesn't change anything. So we have a 4 ohm resistor before this junction. Now we have a 4 ohm resistor after this junction. The circuit doesn't know that. Once we put these resistors in this configuration, 4 ohms in series with a combination of 6 and 3 in parallel, that's what happens. REQ is set up as 6 ohms, and the current just sort of knows what to do. See, the real thing about when you put resistors in a circuit is that it changes the electric field. So, for example, when charges get to this point on the junction, they sense one electric field on this path and different electric field on this path based on the resistances. Charges tend to take the path of low resistance, right? And so a low resistance path offers a stronger field. A high resistance path offers a weaker field. And so the charges get here, they're pulled more this way than they are this way. Some will always go down the path of high resistance, but that's just what happens, right? So not all the charges will go in one particular way. But the point is that when you put this 4 ohm resistor here as well, that changes the electric field in the entire circuit, and the current is just a reflection of that. The charges know what to do, and they don't need to know whether this 4 ohm resistor is here or here. It doesn't matter. Because remember, the charges don't really start at the battery and go around. That's just a convenient way for us to visualize what's happening. The charges are all throughout the circuit. They're in the wires, they're in the resistors, they're in the meters, they're in the batteries, and then once you make the very last connection, the charges all start flowing around together. The information is processed and distributed throughout the circuit all at once, or at least very, very quickly at pretty much the speed of light. And so there's no delay in the charges thinking there's no resistor here, so they're going to drop more voltage here, or less voltage here, or more voltage here. It doesn't matter. It doesn't matter, right? So this configuration of resistors is exactly the same as the configuration of problem 13. There's no difference whatsoever. All right, you have one more problem, it's number 15, but it's more like an optional one if you'd like to try it. It's just extra practice. In class, usually I don't even do it because we don't have time, because I want to get you into doing your FRQs and other things as quickly as possible.